Okay, we have a homework number 4, which is the exam question, one of the exam questions. So, uzun soru. Okay, it's not longer than what it was. Well, we have the second part now. Of course, that relates to information distortion. And I think you're going to get the idea once you settle down and try to solve it at home, of course. Okay, about grading, I was not able to grade anything. I didn't do anything, actually, last week. And so I think I will be able to finish grading on Tuesday and try to announce everything on Tuesday, including the homework number 3. And it's not that probably urgent, but I think I can probably do it during the weekend. Okay, any questions? Now, I think this Thursday, probably I'll announce the papers that I want you to present in this classroom. So what we're going to do is I will give you a selection of papers, and you're going to pick up some papers for presentation among the ones that I give. And of course, I don't know what I actually would ask from the others in the classroom, but I'm going to ask something for the others as well. So I want you to read the papers at least a little bit before coming to the classroom, and so that the span that you're going to have with respect to the supply chain analytical models is going to be even larger with the new models, with the new papers that I include for discussion purposes. Now, of course, I am going to give you support with respect to the presentation in class. So I would ask you to send me the slides of your presentation before coming here so that we will see and we will make some discussions. And regarding the technicalities, of course, you can ask me those questions as well. But I'll try to give you enough time. We are practically, I think, seven students in the classroom. So I'm going to prepare the presentations for those 7 people. Well, there is one missing today. Am I right? Yeah. And, well, there are others, but they are not attending, so probably I'm not going to announce any time for them for presentations. And, well, if they show up, of course I will, but if they don't, I'm not. So, and I will schedule them towards the end of the semester. So you're going to have sufficient time for preparation and so on. Okay. Any other questions or comments? Okay, today I will start to the topic of alliances, partnership, contracts, and so on. And we have a number of papers that we will discuss. And additionally, I'm going to give you some introductory information on contracts, which I believe is one of the crucial topics. But first of all, before going even further, I will start with Pasternak's paper, 1985. And I'm not sure were you able to find any time to read this? Okay, no problem, because this is a relatively easy one. But I would suggest that you would read the others because they are not as easy to understand. Now, this is an early paper by Pasternak in 1985. It was published in Marketing Science. So it is not published in one of the journals that we are more familiar with. And the idea is that it gives one of the initial notions of the contracting issue, the importance of contracting in the literature. Now, I think the work was done probably in 1970, so we're talking about something which is probably 40 years old. Okay? And you're going to see that it's very straightforward, but I think we have 2 important lessons to derive from this paper. Number 1, if you are the first in introducing certain ideas, the analytics of the paper is relatively easy. They are easily readable papers. Okay? But basically, if you are going to build upon this paper, anything that you put upon an initial idea is going to be more complicated. So in that respect, the paper looks simple. Okay, and it is simple. When we look at our knowledge today, after 40 years, it is simple. We have a lot of notions that we know now. But I think the issues that are dealt is probably very original. So in that respect, it is an important paper. Now, the second part is if you have some hypotheses with respect to your model, which we are going to have, it basically shows how very simply, in a very simple manners, how you can show those hypotheses to be true by use of some propositions, theorems, and so on and so forth. And everything is very straightforward because what we're talking about is basically a news vendor problem, and you're going to see. Okay. Now, there are two entities in this paper. One of them is the manufacturer, and the other one is the retailer. And the manufacturer or the supplier actually supplies the retailer. The retailer satisfies the demand coming from the market. So we're talking about a single period problem where the demand is stochastic. The density function is given by f of x, and the cumulative function, cumulative demand function, probability function CDF is given by capital F of x. Now, at this point, we assume that there is no competition. In other words, we only have a single retailer, so there is no competition. So it means that we can assume that the prices are going to be set. Okay? So we can assume that the selling price is set. So selling price of the retailer to the market is P, and it is set. Now, what are the variables of concern in the problem? Well, this is like notation table. C is the manufacturing cost per item. And we have C sub 1 is the price per unit paid by R to M, by the retailer to the manufacturer. So we have a selling price of the item from the manufacturer to the retailer. Now, of course, these are not, this is going to be one of the decision variables. Okay? Because depending on the price, we know that the retailer is going to change the quantity that it buys. Okay, C2 is the credit per unit. Now, this is going to be something that we are going to see a little bit more in the future when we discuss contracts in a little bit more detail. So this is credit per unit paid by the manufacturer. So paid by M to R. So manufacturer pays it for returned items. So it means that here we are assuming that manufacturer can accept items that are not sold as returns. Now C3, we also have a C3, which is the salvage cost or salvage value per unit. It's not the cost, but it's value per unit. So regardless who salvages the item, retailer may salvage the item, or the manufacturer may salvage the item, but both they are going to get some kind of a value out of it. Okay? So you see, this is basically the credit that manufacturer pays to the retailer for any items that are returned. And moreover, R may not return any items or may not be allowed to return any items. And if there are leftovers in the system, this is the salvage value that they get out of it per unit. Okay? Now, P is the selling price. And now we have two types of, well, we have goodwill costs, of course. Let's say that we have a G, which is the goodwill cost per unit stock out incurred by the retailer. So the retailer, which is, let's say that we're talking about a brand name which is sold, a brand name manufactured, let's say, by Arçelik, which is sold in the market by, tell me a retailer. Let's say, well, refrigerators are sold where? I mean, you may know it, you are younger. So which type of retailers sell a refrigerator? Well, we know that Bayi, okay, Arçelik Bayi is going to sell a refrigerator. So if the Arçelik Bayi is not going to have that item, okay, there will be a goodwill cost that's paid by the retailer. So basically it means that the future customers are not going to come to that specific Bayi because they cannot find what they are looking for. Okay, so, but at the top of that, Arçelik has lost also. Why? Because you went to a retailer which is supposed to sell Arçelik. You don't find what you are looking for there. You are pissed off with the retailer. But at the top of that, you're a little bit pissed off with Arçelik, saying that what kind of a distribution system do they have? They should hire me so that I'll design them a distribution system. They are going to have all the refrigerators of the world in every retailer. Okay? So that Arçelik will bankrupt. Okay, so you have this G1, which is the goodwill cost per unit stock out, and this is now incurred by M. Note that when you are selling a brand name, this is what happens. Now, if what you are selling is not a brand name, you don't care about this. So now think about Arçelik again. Arçelik, under different names, are making manufacturing in Turkey. They are not, it's not very important for Arçelik whether the market that they have sold is satisfied, customers are satisfied or not, because they are not using their own brand name. So that's the reason why they are usually paid a lower premium, a lower profit when they do manufacturing. They don't put their name on it. But when they put the name Arçelik, Beko, which are sort of brand names, they are going to charge a little bit more for that. Because they are also going to have some kind of a goodwill cost in case they cannot satisfy the demand. So you can see why the brands, the brand names are going to have more value. And this is basically what we have in this problem as well. Okay. Now, I'm going to define G2 as G plus G1. So this is the total goodwill cost that happens if we are talking about the system. Now, there are decision variables, of course. The first decision variable, well, we're going to see that actually the C1 and C2 are also decision variables. In other words, how should I set as the manufacturer my price that I'm going to sell to the retailer? And what should be the credit that I'm going to give back for the returned items? These are also decision variables. Okay. But other decision variables, one of them is Q, amount ordered by R. This is retailer. And unfortunately, I'm going to have another R here, but this R is going to be sort of the percentage of order quantity, percentage of Q, which retailer is allowed to return for a credit of C2 per item. So in order for, usually what the manufacturers would do will be the following. They say that if you are going to order Q units, I'm allowing you to return 20% back. Okay? So this R is actually that 20%. Now, it's a decision variable. Now, you can see that here, what we have is we have an implicit contract. There is no actual contract, but there is an implicit contract where the contract has the C1 value in it, C2 value in it, and R value in it. Okay, so this is actually a contract structure. Okay, any questions on this? Okay, now let's go further. Of course, there are some natural bounds within the values of C's. In other words, we want the system to be economically viable, okay, and so that there will be some relations. Now, number one relation, C3, which is the salvage cost, should definitely be less than C. In other words, this is basically the unit cost. Okay, of course, the unit cost should be greater than the salvage value. Otherwise, what is the temptation? The manufacturer is going to manufacture indefinitely. Okay, and then, of course, this is going to be less than C1. Otherwise, if C1 is not greater than C, the manufacturer is not going to make any profit. And of course, we expect this to be less than P. Okay. Now, this is one relation. Now, another relation, C3 should be less than C2, the credit which is received by the retailer. Otherwise, if it is not the case, then it's not meaningful to talk about returns. Okay? And of course, C2 should be less than or equal to C1. And this is also less than P. Well, we already have that. Now, here, note that I am writing C2 is less than or equal to C1. And I am allowing for equality. Why do you think I'm allowing for equality? Because you can see that you also have another control knob. You don't allow for everything to be returned. But basically, you say that if the quantity that you order is meaningful, then I am going to buy back a certain percentage, and I'm going to pay you the whole money back, which is reasonable because basically you are sharing the risk of the retailer. Okay, so these are actually natural limits, and we are going to see how these are going to be used further. Okay, now, model 1, there are two models that are sold. Model 1 is sort of a very straightforward case where you assume M and R to be the same system. In other words, you say that, well, Arçelik and the retailer of Arçelik belongs to the same person, which used to be the case actually at some point in time, so that they can make the decisions in a more economic way. So we're talking about a centralized system. So model 1 is actually a centralized system where the decisions of Q, the decision of R is not meaningful. The decision of C1 and C2 is not meaningful because you are basically putting your money from one pocket to the other. Okay? So you only decide on Q. Okay, and it becomes a news vendor problem. So now usually the way that you pronounce this is as follows. If M directly sells the product to the public. Okay, this is one way of putting it into action. Of course, there is a very simple thing which is missing here. If you directly sell it to the market, of course, then what is the role of retailer if you can do it? Of course, you cannot do it. Why? Because the retailer has some kind of a demand span that the manufacturer is not going to be able to reach. Okay? Because probably the retailer is selling some other things as well together with this product. So the customer base is going to be different. So when this is the case, probably the demand that the manufacturer is going to see will be much different. Okay, so in reality, the comparison should be made on that basis rather than this basis. Okay, do you follow this? I think these are sort of important issues. In other words, if M directly sells it to the market without a retailer, this is the way that it is put forward in the paper, then probably the demand that it is going to observe will be different than what we have here. Because the retailer is going to have more base, more customer base, and the demand will be probably larger. This is the reason why you have retailers in the system. Of course, if that retailer is not doing its job, that's something else. Okay. Now, in this case, what will happen? Let's write the expected profit. And so this T stands for the total. And I'm going to have a Q here. So the decision is only Q. So what we have here is simply the following. Now you have minus CQ, which is the manufacturing cost. And then you have the selling part only into action. So if the demand is in between 0 and Q, okay, you sell whatever the demand is. So you are going to have X times P. X is the demand in between 0 and Q. XP is the return that you are going to get. And for the remaining units, what are you going to get? For the remaining units, you are going to salvage. So you are going to get C3 f of x dx. Okay. Now, what happens if the demand is larger than Q? If the demand is larger than Q, you are only going to sell Q units. Okay? And then you're going to pay some kind of a salvage, goodwill cost for the units that you cannot sell. So this is X minus Q. And the goodwill cost that I'm going to pay, and let me use G2 for that, because basically I'm going to pay all kinds of salvage, because I am the retailer, I am the manufacturer, I have the brand name. So I will lose all kinds of different goodwill. So it is going to be X minus Q G2 f of x dx. So what we have here is actually, we have the classical news vendor problem, but now the letters that we use are a little bit different. But it's the same problem. And in these type of problems, actually, if you recall, what we are going to do will be first check the concavity of the function. And what do we do to check the concavity of the function? We talk about the second derivative. Let me write it here. So if you take the second derivative, now here we have only one variable. So if you take the second derivative with respect to Q and check whether this is going to be positive or negative, well, you see that this is always going to be less than 0, which means that we're talking about a concave function. Concave function means that we can maximize this by selecting a certain Q. Okay, so how are we going to solve this problem? We take the first derivative with respect to Q, equate it to 0. Okay, we are familiar with this. We can do this. So as a result, I'm going to obtain this condition, which tells me that FQ optimal, and let me call this Q for the total system, Q sub capital T, should be P plus G2 minus C divided by P plus G2 minus C3. So if you are more familiar with cost of underage, cost of overage, this is actually the cost of underage. P minus C is the lost profit per unit that you cannot sell. and G2 is the additional goodwill cost that you pay, so that's the cost of underage. And this is cost of underage plus cost of overage. And what is cost of overage? For each unit that you cannot sell, actually what you are losing is, you are losing P minus, for each unit that you cannot sell, what you are doing is you are paying C minus C3. So C minus C3 is the cost of overage. P plus G2 minus C is the cost of underage. So cost of overage plus cost of underage is going to be P plus G2 minus C3, which is the denominator. Okay. But again, as I told you, in all these cases, I always write this rather than using cost of underage, cost of overage, because this is going to be a little bit confusing if you don't imagine that correctly. Okay? Okay, this is for multiple choice solvers. That's what I call. Now, you have to understand the idea, but I think this is an easier and more guaranteed approach. Yes?
I think we made a mistake.
Where?
Salvage cost should be minus a goodwill cost.
Okay, you're right. Thank you. Okay. Okay. Okay, so what this means is that if I am operating the system as a single entity, this would be the quantity that I would order. Now, let's consider another model, which is model 2. Actually, this is the only other model which is considered in the paper. And what you do here is you basically apply a hierarchical model. Now, what happens in reality? In reality, if I show the same picture again, in reality, what will happen is that the manufacturer is going to have some kind of an announced price and conditions related to R, the return percentage, and the credit that you're going to get when you return the item. Okay? And given those which are announced, given the prices, the retailer is going to decide on the quantity to buy. So this is actually what happens in reality. In other words, in reality, what happens is that M announces an R, the return percentage, announces a C1, this is called the price, this is called the transfer price, and announces C2, the credit that they are going to give for each returned item within the limit. Okay? And then the R, the retailer, sits down and decides for the optimal values. So this is basically what I mean by hierarchical. So this is basically the hierarchical structure that we see in real life. So then I'm going to call this as EPR, where the retailer actually decides on Q. And what is the expected profit function for the retailer? So let's try to write that function. Now, for each unit that they are going to buy, they are going to pay C1 per unit. And then what will happen? Well, now I'm going to have more limits because remember, I can get a return up to a certain percentage. Okay, so now if the demand is very small, okay, in other words, if the demand is very small, and so what happens is that here I have Q times 1 minus R. What's the meaning of this? If the demand is very small, I would only be able to return a part of the items that remain in my inventory. Okay? Note that I'm taking the upper limit of the integral as Q times 1 minus R. So in this integral, the demand can be at most equal to will be equal to a quantity so that the remaining number of units is the maximum amount that you can return. So any demand which is below this level, which means that you can only return a certain constant, the remaining is going to be in your inventory. Okay? So this is how we are going to write the expected profit. Here we are going to sell X units, everything which is available. So we are going to receive X times P. And then I am going to receive credit for every item that I return. And here I can return my maximum amount, which is RQ. This is the maximum amount that I can return. Okay? And I have to multiply this with C2. I'm going to get a credit out of that. Plus, for the remaining amount in the inventory, I'm going to have the salvage value coming in. So what is the remaining amount in the inventory? The remaining amount in the inventory is Q times 1 minus R time minus X. Is this correct? No, it should be even lower than that. Excuse me. Okay. So this is going to be, what is the quantity which is remaining? The maximum amount, this is the amount available, and I have already returned R here, okay? And then I have X, which is the remaining amount. So if X is, let's see, if X is the maximum amount, then I'm not going to have, well, it's not correct. Okay, I'm going to have this actually. Let me see. Okay, good. Now, the way that I have written this is such that in all these cases, the RQ amount is going to be returned. And the maximum is Q times 1 minus R. So I am simply going to have this quantity times C3 as my salvage return. I have sort of mixed it up. Okay. And so this is going to be the total revenue that I receive once I make the expenditure. So this is going to be f of x dx. Then I'm going to have another term. And this is if the demand is in between Q1 minus R and Q. Okay? It means that all the units that I'm going to have at the end can be returned. So this is going to be simply XP plus Q minus X times C2 f of x dx. Okay, so this is basically the standard term that I have, as if I'm getting a salvage or something else. I don't have limits. Plus, if the demand is more than Q, I am going to receive a revenue for Q units only, Q times P. And then I'm going to have my goodwill cost, which is X times Q times G itself. Okay, so it's not going to be G2 because G2 is the total. So G was, if I'm not mistaken, G was the goodwill cost that the retailer incurs. Okay. Of course, now, this is a more complicated function. Why? In the regular news vendor problem, I only have one limit of this sort, whereas now I have two limits. So the type of the first order condition that I'm going to get is not going to be this nice anymore. But is this function still a concave function? So what you have here is, now if you look at the structure, in general, we are going to have a single term instead of these two integrals. Okay? And note that the costs are linear. Okay? So that the concavity is not disturbed. Now, what we have is we have two integrals. And what is the only thing that we have is here, this C3 is, well, or this C2, here we have a linear function again, but the slope of the linear function is sort of with a little kink. I shouldn't say kink. Kink is something else, but it is sort of like as if you have linear functions again, but the C3 value is less, which means that the concavity actually is not disturbed, if you can see it from here. But the correct way of doing things is what? You take the second order condition again, check the second order condition, show that it is negative. Okay? And here we have the same case. But you can, if you are sort of experienced, you can say that, well, the functional structure is not changing. And moreover, I don't get more advantage by salvaging, or excuse me, by salvaging more, because C3 is always less than C2. So what you are getting per unit decreases as you have more left on hand. And this is not going to disturb the concavity. Okay? Of course, if you were minimizing and if you had this kind of structure, it would disturb it. Because it means that if you were trying to minimize the cost, and if it turns out that the salvage that you get, or the cost that you pay for the salvage is getting less and less as you salvage more, and if it is a cost, then you are getting an advantage out of that. Okay? So in that case, the convexity would be violated. But here we have a concave function, and it's reasonable. Okay, as you go to the extremes, the advantage that you receive is going to go down. This is actually why we have concavity. But again, the correct way is to check the condition. So the first order condition that we are going to obtain will be as follows. So now this is going to be a little bit more complicated. You can actually guess the structure of the first order condition. Now in general, we are left with a cumulative function equal to a ratio. But now we have an additional integral, so that you cannot have a single cumulative function, but you're going to have two cumulative functions coming into picture. One of them is going to be up to this value. The other one is going to be up to this value. Okay? And this is what we get when we have the first order condition. So the first order condition, let me write this here, is minus C1 plus P plus G minus f of q optimal times P plus G minus C2 minus f of 1 minus R q optimal times 1 minus R times C2 minus C3. Okay, let me check the paper. Sometimes I make mistakes in copying the paper. Okay. Okay, yeah. Okay, the type of parentheses are different only. Okay, here I don't need to have this, like, okay, maybe just to make things a little bit more look similar. Okay, so you can see that, and this is going to be equal to 0, of course, the first order condition. So as you see, the more integral limits, separate functional forms in different integral limits is going to bring you, will be simply more f functions in the optimality equation. Now, of course, this is not a very difficult functional form, but you cannot obtain an explicit result. Unless, of course, you can specifically write f of q. Okay, for example, if you have uniform distribution, okay, f of q is much simpler to write, so that you can obtain an explicit form for q if you are talking about uniform distribution. Okay? Otherwise, this is going to be your first order condition. Okay, now, of course, this is not an easy condition. You usually don't know what to do with this type of a condition. But the idea is that if you give the retailer a C1, the transfer price, a C2, the credit that you are going to give back for the units that you accept returning, and an R, this is the equation which is going to determine the optimal value of Q for the retailer. So if I give you certain parameters, the retailer is going to use this equation to optimize the Q value. Okay, now in game theory, okay, this is called the reaction function actually. This is the reaction of the retailer to the parameters which are supplied by the manufacturer. Now, in this problem, we are not going to optimize the profit of the manufacturer. In other words, you can go one step further. Now, you know that the retailer is going to order according to this equation. You are the manufacturer. You can now take this and try to maximize your profit as the manufacturer. Okay? And this is actually what we are going to see later on, but not in this model. Now, of course, as a manufacturer, what should I want? Now, I know as a manufacturer, I can see what's going on. And let's say that I know the G2 value, this P value is transparent. G2 value, the goodwill cost, is not very transparent, of course. C3 is known. So as a manufacturer, if I can figure out what the goodwill costs are for the retailer and for myself, I know the quantity that should be ordered by the retailer, which is going to optimize everything related to the system. In other words, it is going to maximize the total profit that the system gains. So one motivation for the manufacturer is to select C1, C2, and R values so that the quantity which is selected by the retailer is equal to QT star. Okay, so this is one thing that can be done by the manufacturers. Okay, so let me write that. So manufacturer, so let's say M, can select C1, C2, and R values so that Q optimal is actually QT optimal. Now, what is the use of this? Well, the use of this would be simply the following. We know that actually model 1 attains the largest total expected profit. So what we want now is we want C1, C2, R values to induce the retailer a quantity so that we will be able to attain this total cost. However, you can immediately say the following, well, it may not be beneficial for the manufacturer to do so, because the manufacturer, by using another C1, C2, and R combination, may increase her own profits, which is usually the case. So how can we write the expected profit of the manufacturer? Now, given this scheme, what is the expected profit of the manufacturer if Q star is ordered? Okay? So if Q star is ordered, the manufacturer is going to have a profit on the items that are sold. Q star is ordered, so your manufacturer receives C1 minus C as the premium per unit. Okay, again, don't forget, this is the expected profit function of the manufacturer, given that Q star is ordered. And then, but however, there will be some money which is paid back. Now, if the demand is in between 0 and 1 minus R times Q star, then definitely the retailer is going to return the maximum amount. So this is going to be paid. In this case, it is going to be R times Q star units. A credit is going to be paid. However, a salvage is going to be collected. So only C2 minus C3 is the cost that incurs to the manufacturer. So you have f of x dx. Plus, if the demand is in between 1 minus R Q star and Q star, the remaining amount is going to have the same condition, but instead of now R Q star, we are going to have Q star minus X units left. And again, we are going to have C2 minus C3 f of x dx. And then, if the demand is larger than Q star, the manufacturer is going to incur a goodwill cost, which is going to be x minus Q star times G1 f of x dx. So this is the expected profit for the manufacturer. Note that we didn't do any optimization here. We just calculated the effect of this Q star on the manufacturer. Now, of course, one thing that we can do is, if I am the manufacturer, what I will do is I would try to maximize this by selecting C1, R, and C2 appropriately. Okay, this is one thing that I can do, of course. But we're not going to do that at this point. Any questions on this? Okay. Now, after the break, what I will show is, so these are sort of the analytical part. After the break, we're going to show that there are certain C1, C2, R combinations which cannot be optimal. So even if I am the manufacturer, I'm trying to induce certain things on the system, I will be able to show that if I select certain C1, C2, and R values, I would never be able to get this QT star. Okay, there are certain values like that, and we're going to show that. Okay, so that's after the break. Any questions on this? Okay.